In this lecture, we'll be discussing about Kirchhoff's current law. So Kirchhoff's current law is abbreviated as KCL, Kirchhoff's current law, and it states that the algebraic sum of currents meeting at any junction in a circuit is zero. So we know what are junctions. Junctions are nothing but the point at which two or more circuit elements meets. So if we consider one such node in a particular circuit, the algebraic sum of all the currents meeting at that particular node will be zero. Okay. So now what is algebraic sum? So algebraic sum means we are calculating the sum of a number of quantities considering the sign of each of the quantity. So while calculating the algebraic sum, we need to consider the sign also, whether that particular quantity is positive or negative. So that is algebraic sum. Okay. So for calculating the algebraic sum of currents, we need to know the sign of current, whether that current is positive or negative. Okay. So as an example, let us consider a particular point A. So assume A is a node or a junction in a particular circuit. So A is a node in a particular circuit and there are 5 currents I1, I2, I3, I4 and I5 meeting at this particular node A. Okay. So we need to calculate the algebraic sum. According to Kirchhoff's current law, the algebraic sum of all these currents will be 0. So we need to calculate the algebraic sum. So and for calculating the algebraic sum, we should know the sign of current, whether that current is positive or negative. And that sign depends on the direction of flow of current. And by convention, all the currents entering into a node are taken as positive and all the currents leaving from a node are taken as negative. So all the currents entering into a node are taken as positive and all the currents leaving from a node are taken as negative. So now let us apply the Kirchhoff's current law. So I1 is a current entering into this junction. So I1 should be taken as positive. So I1 plus, we need to take the algebraic sum. So I1 plus I2. So I2 is also an entering current. So it will also be positive plus I3. I3 is a current which is leaving from the junction. So its sign should be negative. So minus I3 plus I4. So I4 is again entering into the junction. So I4 will be positive plus I5. So here this current I5 is also entering into the junction. So we have considered only one leaving current. So just consider this current I5 as leaving from the junction. So I5 is a leaving current. Okay. So I5 as it is leaving from the node, it should be taken as negative. Okay. So it will be minus I5. So according to Kirchhoff's current law, algebraic sum of all the currents meeting at a particular point or a junction in a circuit will be 0. So we have considered the algebraic sum of currents and this will be 0 according to Kirchhoff's current law. So now let us rearrange this particular equation by keeping all the positive quantities in the left hand side and taking all the negative quantities to the right hand side. then the equation will become I1 plus I2 plus I4 is equal to I3 plus I5. I3 and I5 goes to the right hand side. So I3 plus I5. So using this particular equation, we can define Kirchhoff's current law. We can state Kirchhoff's current law in another way. See here, I1, I2 and I4. I1, I2 and I4 are currents entering into the junction, and I3 and I5 are the currents leaving from the junction. I3 and I5 leaves from the junction. So this can be stated as the sum of currents entering into the junction is equal to the sum of currents leaving from the junction. Okay, so Kirchhoff's current law can also be stated as the sum of currents entering into a junction in a circuit is equal to the sum of currents leaving from that junction. So here we have to take the arithmetic sum, not the algebraic sum. But here it is the algebraic sum. So either the algebraic sum of all the currents meeting at a junction in a circuit is 0, or sum of currents entering into the junction is equal to sum of currents leaving from the junction. So here this is the arithmetic sum. So we can state KCL as arithmetic sum of currents entering into a junction is equal to arithmetic sum of currents leaving from the junction So this is Kirchhoff's current law.